Hello, this is the third episode of the Industry Briefs blog for my assignment. This week, I continue to develop my basic enemy AI in full force, building upon it. As mentioned last week, I wanted to dive in the EQS system and begin developing a basic understanding of how it functions before creating a basic use for the AI to find the closest cover point when shot at by the player. Tackling this part of the project was tricky at first, since I didn't really have a starting point for research in a specific area. Ultimately, I referred to the Unreal Engine 5 documentation to help me navigate a very basic setup. This covered some of the basic AI procedures of making blackboards and behavior trees, which I read through but didn't gather much additional knowledge from. It was going to show me how to make the enemy always find the best spot to see the player. The documentation showed me that to use EQS, I had to start a query and assign different tests to help the AI navigate appropriately. This documentation also ran me through creating my own query context to allow the AI to check for a specific actor within the level, which in this instance was just the player. Inside the query itself, I could pass in the trace test to find the player, and then work out the closest viewing distance to the player. Tying this up with my behaviors, I followed the documentation's behavior tree setup and the AI controller setup just to further my understanding. Finally, my AI could patrol around on its own, but as soon as it caught sight of the player, it would wait for them to disappear from view and then trigger the AI to move to the specific location. A little knowledge I did gain from this that was super helpful was the AI perception component, where I could give different senses to the controller. For the time being, I have provided the site config so that when the player is seen, it runs the behavior to run the EQS. I also had an issue with the documentation. Later in the EQS section, it shows me how to create and set up an EQS testing pawn to draw the EQS on the screen for me to visually see whilst editing parameters inside the query itself. The documentation shows a specific override function which I can't access or utilize, but I can still see the query when it's assigned in the level. This, however, did prevent me from seeing the development of my actual goal as I created it, since it couldn't properly detect the player. Although this process of finding the best viewpoint on the player isn't something I need, this was incredibly helpful and helped me understand creating queries, running them, and executing behaviors based on the data they produce. This helped me significantly in understanding what I needed to use and work on to accomplish my current goal. Moving on from my introduction, I began reformatting my query to now work in line with my goal. This was relatively straightforward to achieve, only required me to switch my query to trace for cover. For this, I used a pathfinding test to discard any unreachable spots, before tracing where the player currently is and finding the distance to a point where they can find cover. Finally, I swapped out the random location behavior to be my EQS query instead and tested how the enemies responded. I am satisfied with this outcome. It works exactly as I intended on an individual basis, but testing in actual groups is also something I need to consider. Since they will all run the same behavior, there's a huge likelihood that they will run to the same small cover, so I should consider a way around this so that the AI still seems tactically smart. This also helps me to achieve one of my other behaviors I want from my AI, since the player will have the opportunity to shoot them in the open. I wanted the option for them to hide be a viable choice, so that the challenge becomes a little more difficult and the player is forced to approach the enemy or utilize a grenade in order to successfully kill them. This did lead me to a very small issue where the player can still shoot the enemy when they are crouched behind the cover. To simply fix this, whenever they change state, I also half the capsule size, keeping them covered, and vice versa when they stand back up. Finally, I wanted to take into consideration the movement speed of the enemies. I started by changing the max walk speed in the character movement component, but soon realized that this is not how the ALS works out speed. So I did begin diving into the pre-established code for the player and enemies to find out where this can be modified or how I can work around this issue. Moving into next week, I want to continue to figure out how the player and enemies calculate their speed, for different states, and further the behavior to know when the player is reloading or has run out of ammo, so that the enemy will press the attack on the player. I also didn't create a crosshair for the player, which I mentioned last week, so I shall put that as a priority this week.